Going on, Mr. House Builder? Got you all sewed up here, big brother. I hate that you had to bring this bad boy back, man, but two different reasons, completely unrelated. First time this Palomar Super Base 1000. First time this bad boy was in here. Done some power supply work for him. Put this 100 amp bridge in here. New cap for him. I think there was 2 caps in there. Put him a cap that's a little bit bigger than both of those 2 caps were. And this will show you, man, these bridges, man, they don't play. We got 2 transformers on 1 bridge. That's because those are 250s on 1 bridge. Can't beat it, man. It's called efficiency. But the way they got them transformers wired up, man, I went ahead and looked at them. I can tell they've got them wired up on the medium tap of them. So you could go up on the high tap, man, but dude, I mean, this thing's performing well. It's running on low voltage. Your stuff's gonna last. I mean, I just leave it. I mean, this thing's doing almost 400 bird. Just with a bench radio, just with a 4-watt radio, man, on 14.2 volts. Around there. I mean, this thing's cooking. Plus, I mean, these 1446s, man, these things are driving these things nice. Now, I will warn you, when I turn this box on, this is one H of a fan. This is one heck of a fan. This fan right here, man. This is one impulse width modulation fan. This cat picker right here blows some air. I will tell you that right now. It is a little loud. It is a little loud. Too much for one regulator. I'll tell you that. This thing pulls too much amperage for one regulator. That's why I just got that 10 ohm 5-watt right there. But anyway, what had happened, man, is you got lucky. I thought you had blew a transistor, because I could tell you had blown your combiner. Your balancing resistor on your combiner. And I thought you had blown a transistor, man. I went ahead and popped all the legs up on the transistors and checked them. Hell, that took 30 minutes. But after that, I started cleaning up some of this flux just so I could see real well. You know, it had a lot of flux on it. And I quickly noticed, man, that this trace that's leading the power to this output transformer had literally popped. And I'll be completely honest with you, that is a weak part of this amplifier, if you ask me. These are the chokes that were on it right here. Okay, I mean, which is fine. This is a 18 gauge wire. Nothing wrong with that at all. I just replaced your chokes with a little bit bigger wire for you. But power wire comes right here, power wire comes right here. The way those chokes sit is one side. Let's see if I can't zoom in for you right here. You might even be able to see where it popped right there. Let me get something pointing here. Here we go. Nah, I ain't pointing with nothing metal. Let's point with this right here. This Q-tip. Right there. See that right there? See that black part right there? It's the burnt trace. Alright. From that point to that point is just thin foil. And that's the part that popped. So you're talking about up to 50 amps. Possibly. Needing to flow on that thin foil. I guess about the only thing I can think of is it just finally got hot and popped. I mean, I don't really know of any, I don't see any indication of anything. I mean, I had to take this coax off right here too, man, just to pop these transistors off. I don't see any kind of indication of anything else. I mean, I will tell you that since I did that power wire upgrade for you by dropping that bridge in there, getting them squares out there, and the few things that I did do, I mean, I know the amplifier is getting more amperage now. I do know that. You might even have seen the watts come up just a tad bit now that I put these on here. I had to watch the last video to see. That's just speculation. But basically, I think it just got hot and popped, man. So just to be safe, I went ahead and took both those chokes off, and we got it going back to the back of the transformer. Now that's really where it needed to be. The way these were set up, it was following a trace to the bottom part of the transformer. So we just bypassed that trace, and we got it direct fed to the back of the transformers now. I replaced your balancing resistor right here, and that's all I had to do, man. This thing's back up and rolling, so you're going to get you a cheap bill on this one. In your metering circuit right here, I can almost guarantee you get that diode and change that diode right there. I bet you it'd be working. If I can find some time, I know that ain't why you brought it over here, but if I can find some time before you get it back, I may take that diode off real quick and see if it does. The meters, the way the meter's hooked up and designed, I don't know if all the super bases are this way. It's not reading the output of the amplifier, it's actually reading the inputs. I don't really know what good that, I think someone just put that on there if it did not come with the amp, just to make the meter move. It's just reading what you're putting in, because the RF comes from the variable, not in series, so it just comes from the variable in parallel to the meter right here, and then it grounds to the board. So it's just reading what you're putting into the box. So I don't really know what of use that would be, to be honest with you. I mean, I guess you can make anything be of use of something. But I'm not even going to drive this bad boy with the hot radio, because it's just going to lay this supply down probably near 13 volts even. But it's cooking, man. It's cooking. Let's go ahead and show you that now. I noticed we got a 1 watt dead key. That thing's about to turn on. There it is. Got a 1 watt dead key with it turned all the way. I mean, got a 1 watt dead key come from the radio, turned all the way up. I noticed gives us about a 180 watt dead key. This is your voltage on your supply right here, just to show you, okay? Dead key, it drops to 15.4. 1000 watt slug. Look at that. That's right there, 380 watts already, man. Almost 400. Here's your drop right here. 14.2 volts. Peak. In the corner. 1000 watts. This thing's stroking, man. Like I said, if I hook up the hot radio, I'm sure everybody that watches my videos already know you're gonna be over 400 bird. I'd probably guess about 450, but like I said, it's gonna lay these supplies down, man. And I would not drive much more power into this box than that. I mean, it's a 2x4 anyway. This box is designed for low wattage radios. Low wattage radios. The bench radio I'm putting in this thing, I would not even go any higher than that if it was my box. Okay? I mean, you're getting $1,000 out of it on 14.2 volts, hitting it with a 4 watt radio. I mean, how much more, what more can you ask for? These 1446s are very efficient transistors, way more efficient than 2879s, power-wise. And that's a good thing, count to the supply setup that's in here. But I mean, you're running on low volts, man. I mean, kicking butt. I would leave it. I mean, we're talking about probably a quarter of a watt increase will put you at 400 bird. But hey, who's counting? All right, big brother. Well, we got you back up and rolling, man. Hopefully this thing will last for multi years, and you won't have to bring it back. Mr. Housebuilder, your homeboy, Mr. Gatekeeper, man. I'm sorry about the wait, man. I know we stacked up over here in repairs and bills. Oh God, I got my work cut out for me, but hey, one day at a time. All right, big brother. Well, I hope you enjoy this thing and it lasts you a lot longer than the amount of months it lasted you the last time you had to bring it by. But like I said, 2 different problems, totally unrelated. Hey, it happens. Hey, man, you did not blow a transistor. That's the main thing. $65 a piece. Good God, thank the Lord. 73rd to you, bud. Bye-bye.